Good day to you. This is Mr. Mulenga, your teacher of geography. So today I want us to achieve quite a number of objectives as we look at weather and climate as our topic. Now, one of the objectives that I want us to achieve by the end of the lesson is to describe humidity and its measurement. I also want us to explain atmospheric pressure and its measurement. We also identify the instruments used to measure wind speed and wind direction. I also want us to describe sunshine and its measurement. We also discuss cloud cover. So these are the main objectives that I want us to achieve by the end of the lesson. So I'm going to take you straight into the concept of humidity. Now, when we talk of humidity, we are simply looking at the amount of water vapor that may be present in the air. Now, there are two types of humidity. There is absolute humidity and relative humidity. Absolute humidity is the measure of the actual amount of water vapor or moisture in the air, regardless of the air's temperature. So when we say absolute humidity, we are simply talking about the actual amount of water vapor present in the air. The actual amount of water vapor present in the air, regardless of the air's temperature. Now, relative humidity is now the ratio expressed in percentage of the amount of water vapor air can hold at a given temperature to the actual amount of water vapor in the air at the same temperature. So what this simply means is that when we say the relative humidity, we are talking about the ratio of the actual amount of water vapor in the air at a given temperature to the water vapor air can hold at the same temperature. Now, relative humidity is expressed as a percentage. For example, if RH or relative humidity is 60% at the temperature of 30 degrees Celsius, then air is only holding 6 tenths of the water vapor it could hold at the same temperature or at that temperature. So the maximum quantity of water vapor that can be held by the air is known as the saturation point. So when we say air is saturated, we simply mean it has reached the maximum level of holding water vapor. And it is at that point rain starts to fall. So this means air is saturated when the relative humidity is 100%. Now, how do you measure humidity? Now, an instrument called hygrometer is used to measure humidity. This consists of a wet bulb and dry bulb thermometers. So this is how a thermometer looks like, with a combination of a dry bulb thermometer and a wet bulb thermometer. Now, a wet bulb thermometer, as you're able to see on one end here, is that on one end there's a cloth which is dipped in water. So the cloth that is in water depicts a wet bulb thermometer. So the combination of a wet bulb thermometer and a dry bulb thermometer make an instrument known as hygrometer. Now, these thermometer readings, they show something on the amount of water vapor in the atmosphere. So when there is a large difference between a dry bulb thermometer and a wet bulb thermometer, when the difference in temperature readings is very high, then it means there is low humidity. So when there's a large difference, so for example, if the dry bulb thermometer here is showing us 15 degrees Celsius, and a wet bulb thermometer is showing 5 degrees Celsius, the difference between the dry bulb and the wet bulb thermometer is 15 minus 5, which is going to be 10 degrees Celsius. Now, that is quite a small difference. So when there's a small difference, it means there is a very high humidity. Humidity is very high. So when there's a large difference, it means there's low humidity. For example, if the 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 dry bulb reading is 40 degrees Celsius, and that of the wet bulb is 5 degrees Celsius. The difference there is going to be now 40 minus 35, which is going to give us, 30 minus 5, which is now going to give us 35. And that is a large difference, and it means there is low humidity. So the larger the difference between the dry bulb and the wet bulb temperature readings, the lower the humidity. And the smaller the difference between the dry bulb and the wet bulb thermometers, the higher the humidity. Now, when there's no difference at all, when the wet bulb reading temperature is the same as that of the dry bulb, it means air is saturated and the humidity is very, very high, and it has reached 100%. Atmospheric air pressure. That's another very important element of weather. Now, when we say atmospheric pressure, it is the weight air exerts on the Earth's surface. So one thing that you must know about atmospheric pressure is that air has weight. So air has weight, and the weight that air exerts on the Earth's surface is what we call air pressure or atmospheric pressure. So air is made up of a number of mixed gases which have weight. It therefore exerts a pressure on the Earth's surface which varies from place to place and time to time. On the maps, places of equal pressure or places of equal atmospheric pressure are joined by lines known as isobars. Isobars, these lines, isobars. So atmospheric pressure varies with both temperature and altitude. So these are the key factors that determine atmospheric pressure, temperature and altitude. But how does temperature affect pressure? Now, temperature and air pressure will show that high temperature causes air to rise. You must know that when air is hot or warm, it becomes lighter. So high temperatures cause air to rise. This lessens pressure acting on the Earth's surface. Hence, high temperature areas are associated with low pressure. When there is too much sunlight in an area, for example, it warms up the air, and when air is warm, it becomes very light, thereby rising up, causing or creating a vacuum. And these areas of continuous low pressure are what we call doldrum areas. So these are doldrums. Doldrums. Low temperature areas are commonly associated with high pressure. This is because air is always descending when cool. So cold air is heavier than warm air. That is the principle. Now, altitude is another very important aspect. Now, when we say altitude, altitude is the height above sea level. Air is compressible. Air which lies lowest is greatly compressed and therefore densest. So upwards, both density and pressure falls rapidly. So here in this diagram, we have point A, B, and C. So if I'm to ask you a question to say between point A, B, and C, which one has the highest atmospheric pressure? The answer should be A, because places which are lowest are greatly compressed, therefore densest. So at point A, you'll find higher, atmospheric pressure. Compared to B, then the lowest atmospheric pressure will definitely be at C. So the higher you go, the lower the atmospheric pressure becomes. Measurement of air pressure. Now, the instrument that we use to measure atmospheric pressure is a barometer. You must know that. A barometer. Air pressure is measured in a unit known as millibars, MB. Now, there are two types of barometers. These are mercury barometer and aneroid barometer. The mercury barometer is a very accurate instrument, although difficult or cumbersome instrument. A mercury barometer is an inverted tube with a vacuum at the top. The open end is placed in mercury bath. The pressure of the air forces the mercury up the tube. The height of the mercury gives the air pressure. Now, this is often quoted as inches of mercury. Low air pressure usually suggests changeable weather. High pressure usually means stable weather. So this is a mercury barometer. Like I said earlier, it has an inverted tube with a vacuum at the top. So whenever you see such an instrument, you must always remember that this is a mercury barometer. Aneroid barometer. Now, this is how an aneroid barometer looks like. An aneroid barometer. Very different from, a mercury barometer. Now, this instrument consists of hollow metal box, which contains very little air. Now, the top of the box is flexible so that it expands and contracts according to changes in atmosphere pressure or atmospheric pressure outside the box. So basically, this movement operates a hand which is read against the graduated circular gel. Now, this is clearly how an aneroid barometer looks like. There you go. This is an aneroid barometer. Now, if they ask you a question in an exam to say between aneroid barometer and mercury barometer, which one is more accurate? The answer should be mercury barometer. Now, let me take you straight into another very important element of weather, which is wind. Now, when we look at wind, we are simply looking at air in motion. So by definition, wind is air in motion, and it has both direction and speed. So wind direction is measured by an instrument known as a wind vane or windsock. As wind direction is always deflected by trees and tall buildings, wind vanes need to be created in an exposed position to get, a true direction. Winds are always named from the direction they blow. So this means that an east wind is one that blows from east to west. A southwest wind is one that blows from south to west. So Wind is always named from the direction it blows. So you must be able to understand to say when you talk of wind, you are basically looking at the direction in which it is blowing. So in this case, here is a windsock. So this instrument you're seeing here is the windsock. Now, this windsock is showing us the wind direction. As you're able to see, the wind is blowing in which direction? So on this side, we have the east. On this other side, we have the west. As you're able to see on the wind vane here, we have the west, we have south, we have east, and we have north. So this compass will be able to show you the direction in which the wind is blowing. So if the arrow is indicating this sign, it means the wind is blowing from the north. The same as this. The wind is coming from the north. So this is the northeastern side. So these two instruments, the wind vane and the windsock, are there to show us the wind direction. Now, what of wind speed? Now, the instrument that we use to measure wind speed is known as anemometer. On weather maps, places of the same wind speed are called isoplates. Isoplates. It consists of 3 or 4 semicircular cups. That's an anemometer. So an anemometer consists of 3 or 4 cups attached to the ends of horizontal spokes mounted on a high vertical shaft. Metal caps are fixed to the ends of the arms and they do rotate when there is wind. The movement operates a meter which records the speed of the wind in kilometers per hour. So the units of wind speed are, kilometers per hour. So this is how an anemometer looks like with these cups, semicircular cups. Let's get straight into sunshine as our other element of weather. Now, sunshine is quite, evident. I'm sure wherever you may be, you definitely have experienced some sunshine. Even in the coldest places, you see sunshine or you experience sunshine. Now, the amount of sunshine a place receives depends on the seasons, a factor determined by latitude and by the position of the Earth in its revolution around the sun. So when the Earth is very close to the sun, you experience more sunshine, like we do in October. And when the sun, or let me say, when the Earth is very far away from the sun, when it is revolving around the sun, we do experience very, very little sunshine. Now, in the tropics, sunshine is abundant. When we say tropics, we mean the Tropic of Cancer and the Tropic of Capricorn, where, for example, Zambia lies in the Tropic of Capricorn. So, in the tropics, sunshine is abundant, and at the poles, there is less or no sunshine, the North Pole and the South Pole. An instrument which is used to measure sunshine is called the Campbell-Stokes sunshine recorder. The Campbell-Stokes sunshine recorder, through which sun rays are focused upon a sensitized card graduated in hours. So on the maps, places with equal sunshine duration are joined by isohells. So isohells are lines which join places of equal sunshine on a weather map. So this is how a sunshine recorder looks like. So usually sunshine is recorded in hours. So that's how a sunshine recorder looks like in reality. Now, clouds. Cloud cover, if you are to go outside and look at the sky, probably you will see some clouds, especially during summer. You will see some clouds during the rainy season because it is clouds which bring about rainfall. Now, when air rises, it is cooled by expansion. After dew point, which is, or should we say after dew point has been reached, cooling leads to condensation of water vapor in the atmosphere. Tiny droplets of water vapor which are too small to fall as rain or snow will be suspended in the air and float as clouds. So clouds are just very tiny droplets of water vapor. Their form, shape, height, and movement tell us a great deal about the sky conditions and the weather we are likely to experience. I'm sure you've had experiences where you see a certain cloud which is very dense and full of water vapor, and you start running because in a minute or two there will be a very heavy down. So clouds, tell us a great deal about the sky's conditions. Now, the amount of cloud cover in the sky is expressed in eighths or octaves. Eighths or octaves. So what this simply means is that, for example, 2/8 is quarter covered. 4/8 is half covered. 6/8 is 3/4 obscured. 8/8 is completely overcast. So that's how you measure, cloud cover. But there is no specific instrument that you use. What do you use instead? You're gonna use your naked eyes to observe cloud cover. And places of equal degree of cloudness are joined by lines known as isonefs. Isonefs. So cloud cover can be observed using your naked eyes. So as you're able to see, these are clouds. These are clouds which bring about rainfall. So these are cumulonimbus clouds. So we have different types of clouds. Now we're going to look at types of clouds at a later stage. We're going to look at this in detail at a later stage. Now, when we look at cloud, they show us, the conditions of the atmosphere. So as you're able to see here, there are very few clouds, you see, which is 0 to 10. And we have maybe 1 or 2 isolated ones, scattered ones, broken ones, and overcast, which is completely cloudy. The entire sky is cloudy. So this can be done by your naked eyes. You can observe that. Now, in summary, the elements of weather include temperature, rainfall, humidity, atmospheric pressure, cloud cover, sunshine, and wind direction and speed. Now, I'm going to take you straight into the exam questions. So this is an extract from the 2020 paper 1, social studies. Now, this is geography. Study the diagram below and answer question 9. What is the name of the weather instrument shown above? So, Here we have mercury and we have container in which mercury is, and we have pressure of air being exerted on mercury here, and we have a vacuum there. What is the name of the weather instrument shown above? Is it an anemometer? No, anemometer has cups. Is it a barometer? No, this is not how a barometer looks like. Is it hygrometer? No, this is not how a hygrometer looks like. Is this a thermometer? No, this is not how thermometer looks like. So now what is the answer? Yes, so I was teasing your mind. I wanted to see if you know the answer. So the best possible answer here is a barometer. A barometer is an instrument that is used to measure atmospheric pressure. So this is exactly how a barometer looks like. And to be specific, this is a mercury barometer. We said there are two types of barometers. We have a mercury barometer and an aneroid barometer. So this is a mercury barometer. A hygrometer has a wet bulb thermometer and a dry bulb thermometer. Remember that. Anemometer has cups, circular cups, 3 or 4. So always remember that. So the answer here is B, which is barometer. The other question here, what is the name of the weather apparatus above? Now, this one is simple. Remember, we have a wet bulb thermometer and a dry bulb thermometer. Together they form what? They form hygrometer. So the best possible answer here is C. Another question. Study the diagram below and answer question 10. Now, what weather instrument is this? What element of weather is measured by the instrument in the diagram? So this instrument is a wind vane. This is a wind vane which measures wind direction. Rainfall is measured by a rain gauge. Humidity is measured by hygrometer. Cloud cover, you can clearly, see using your naked eyes. So the best possible answer here is D, which is wind direction. Another question. Study the diagram below and answer question 10 and 11. Now, what weather instrument is shown above? Now, this is the Campbell-Stokes sunshine recorder. So the answer is D, sunshine recorder. So I would like to thank you for your time. I'll see you in our next meeting when we look at another very interesting topic which I will introduce. Have a lovely day.